course, I was a biology student, but my formal involvement with research was in the radiation experiment at El Verde field station here in Puerto Rico. That's when Howard Odom and many scientists from the States and other parts of the world came to Puerto Rico to irradiate a tropical rainforest. Well, my dad, he was a botanist, or he is a botanist, and I don't know how much influence he had on me, but obviously I remember going to the field with him, and I remember his professor, Dr. Ismael Vélez, who was a taxonomist, a Puerto Rican taxonomist. But at the time that I used to go with them at the field, I didn't pay any attention to the biology. I was more interested in the sports. But formally, I attribute my interest in research in a professor from the University of Puerto Rico, Dr. Graciela Candelas. She's the one that got me involved in science. And of course, Dr. Howard Odom, who was the project leader in the radiation experiment. He was my boss, my mentor. He hired me, and he influenced all my ecological thinking from an ecosystem perspective. My career started in the radiation experiment, where I did my master's thesis looking at seedlings in the rainforest. But the big question that we were trying to answer in those days, and I'm talking about the early 1960s, was the effects of radiation on tropical forests. And at the time, the United States were thinking about opening a new Panama Canal with atomic weapons. And so it was necessary to understand how complex tropical forests reacted to radiation exposures. And that, of course, unknowing to me at the time, led to the whole issue of how rainforests respond to disturbances. So from the beginning, the big question is, how do complex ecosystems react to disturbances, whether they be anthropogenic disturbances, such as human deforestation or radiation, and natural disturbances such as hurricanes. So if we move forward, 20, 30 years after the radiation experiment, when I became part of the US Forest Service, and we started trying to publish a lot of the work that was being done in Puerto Rico, the big challenge was to overcome the island bias, the anti-island bias in the literature. Reviewers have always looked at research in Puerto Rico as something that is unusual. For example, because we're an island, and there's a lot of people in Puerto Rico, anthropogenic factors are very important in the disturbance of forests here. We started describing phenomena that was unfamiliar to reviewers whose research was based, let's say, in the vast Amazon basin or in the vast forests of Central America, in forests where perhaps the human effects were not as obvious as the human effects in Puerto Rico. And so a lot of the research that we try to publish was rejected because it was seen as unusual. Puerto Rico was always looked as an exception. Of course, that was not true. Puerto Rico just was ahead of the other countries. Puerto Rico was ahead in deforestation. Puerto Rico was ahead in reforestation by natural means. Puerto Rico was ahead in the urbanization phenomena. And so it appeared that we were oddballs, but in reality, when you look at it over time, you realize that the world was just catching up to Puerto Rico. Well, the cool part about tropical biology is, it's so complex and gives you so many opportunities, and you can just dive into it and, never look around. But Puerto Rico, again, has been different because in the radiation experiment, Odom was able to bring a great variety of biologists to work together in trying to understand the response of the forest to radiation. So the first challenge was, okay, how do you get population ecologists talking to ecosystem ecologists? And that was a blast. And it was very interesting because at the beginning it was like a fight. Each one had a different paradigm of how the world would function. And after 30 or 40 years of interaction, we now realize that we all complement each other. And that in fact, ecology makes a lot of sense when you look at it both from the ecosystem perspective as well as from the population perspective. So that was a great challenge that turned out to be a lot of fun and very productive. After that, the next challenge was to get foresters and ecologists talking to each other. Ecologists, well, you know, we like to study undisturbed ecosystems and we like to look at nature pristine, whereas foresters are trying to solve problems, and they usually deal with degraded lands, and they have to do restoration, and they have to do a lot of things that initially used to clash with the ecological point of view. One looking at nature pristine, the other one trying to restore degraded nature. And again, that was a lot of fun. It was a heck of a challenge. But now you hear ecologists talking about restoration, and in fact, ecologists now try to behave like foresters. And foresters, of course, are very ecological. And so that was an interesting challenge that, again, has played out just like the ecosystem population dichotomy. It turns out that it's not a dichotomy, it's just different perspectives, different views of a complex issue, and then you can put them together and you make a lot of sense, and you learn from the interaction of the fields. And the one that I'm working on now is social ecology. That is, you know, then let's say that you do ecology that takes into consideration population and ecosystems, and you do ecology that takes into consideration restoration, degraded lands, as well as pristine lands. The next thing is to put humans in the equation, and that's social ecology. Now, how do you get the sociologists and the economists and the anthropologists and the historians talking to ecologists? How do you develop a common language, and how do you develop the ultimate integration, which is to try to understand the complexity of ecological systems in the realm of social environments? And that's the one that is in progress right now, and it's one that, again, just like the others, is a lot of fun, because you realize that you're all pursuing the same thing. You use different languages, different approaches, but once you get over that hurdle, then you have new coalitions of understanding and knowledge that result in a lot of new insights into ecological systems. Now, you know, that we have, you know, spent decades looking at pristine nature and realized that humans have been a factor all along in the molding of ecological systems. The new questions that we're addressing are questions about the novelty in ecological systems. That is, when you incorporate humans into your research and you look at how ecological systems respond to human presence and human activities, you realize that there are many natural responses of ecosystems that result in what we call novel ecosystems. That is, ecosystems that behave naturally but that are responding to human activities. And that breaks the last dichotomy that we had in our field. We used to think that humans are evil, that humans contaminate nature, if human pollution is what affects natural systems. But in fact, natural systems are way ahead of us, because natural systems have been adapting to human presence all along. And so looking at novelty, the new ways in which ecological systems respond to human activity is the new question that we're trying to follow here. And let me tell you, that question is a lot of fun, because all of a sudden you realize that in the middle of the city, you have wetlands, you have forests, you have ecological systems that, you know, a decade ago you didn't pay any attention to because you thought they were trash. But when you start looking at them ecologically and scientifically, you realize that these are organized systems, that they have all the attributes of ecosystems, and they provide ecosystem services, and they function naturally. And it is all thanks to this idea of self-organization, of the development of novelty in the functioning of natural systems. Well, of course, the future is already here, because the way that tropical biology is heading is towards the Anthropocene. And the Anthropocene which is the era of human domination over the earth, is already here. You know, in Puerto Rico, 75% of the forests of Puerto Rico, of the natural forests of Puerto Rico, are novel ecosystems. They are ecosystems that are responding to human activity. The Anthropocene plays out very effectively in islands where you have concentrations of people and you have nice boundaries and you have limited areas, and there's no other choice for systems to do than to adapt to each other. And so understanding the relationship between humans and ecosystems is really the challenge of tropical biology. Tropical biology has always taken advantage of the complexity of the tropical system. Well, that complexity has enormous potential and capability to adjusting to anthropogenic effects. And so the tropical biologists now have the challenge of looking at the relationship between people and ecosystem, not as a pollution or as a stress, but as an interaction that results in novel combinations and in new types of ecosystems, but functional ecosystems. And so defining the function of novel ecosystems, studying the ecological services that you get from these novel ecosystems and how humans and nature adapt to each other, I think that's the big challenge of tropical biology in the 21st century.